I recently figured out how to repurpose this 3D modeling software called Cinema4D as a tool for plotting data. This software allows you to control multiple attributes of an object, like its position in space, its rotation, its size and shape, and its color. Because we can control all these properties simultaneously, we can use this to visualize multiple mathematical functions at the same time in the same space. And that's something I had personally never seen done before. I had to know what it was going to look like. You are going to see the end results of this project that I haven't even started yet. All I have is like the seed of an idea. I'm gonna walk you through my creative process for how I come up with some of these simulations. I'm gonna attempt to talk about it as I see it in my head, and we're gonna go from there. So I'm not totally starting from scratch because I had done a project like this in MATLAB years ago where I had this wave that would propagate outward, and that wave would control the rotation angle and the magnitude of these little vectors. And I got some really cool results with that. Now that I can use Cinema4D to plot objects, I can control way more properties of these objects and do the same thing, but superimpose a whole bunch of different functions that control way more different properties, and see how that looks. So that's my idea in a nutshell. There are two key math concepts that underlie this project. The first is a polar coordinate system. You can define any point in 2 dimensions using just the x and y coordinates, or you could define it using the point's radius from the origin and the angle that that point makes with the x-axis. The second component is this expression for a traveling wave. I used this one expression for almost everything that I made in this video. It's a function of r, which represents space here, and t, which is time. The quickest way to understand this, I think, is to look at how each of the 4 parameters affect this function. The amplitude A represents the height of the wave. W controls the spatial frequency. V represents the wave speed, so how quickly it's moving to the right. And B is just the midpoint of the wave, and it's usually equal to 0. So now in polar coordinates, we can plot this as a function of the radius r or the angle theta. And these 2 functions are the only 2 functions I used in my visualization that I'm going to show you. What would it look like if we had one wave controlling the size and another controlling the rotation? To me, it's not something that my brain can process. All right, now that we got that math stuff out of the way, we can get to the fun stuff. Gotta be hydrated. So many times I've forgotten water. Now we're ready to go. Okay, I think I'm ready for this. Oh my God, look at this. I think we're gonna need to go to a slightly less windy part, stop here before we start talking about the project. And so what I plan to do is to create this rectangular array of these objects, basically use that function I just showed you to control each one of these properties separately. So it's been 3 weeks since I recorded that, and we're finally ready to see these results. It was actually a lot harder than I thought. I'll put a link in my description to my code repository, but I don't think I've found the most elegant solution yet, so I'm not going to go into detail in this video about how the code works. Each one of these visualizations is going to be defined by a total of 9 different equations. We can control the color through 3 properties, the red, green, and blue color channel values. We can control the rotation around the X, the Y, and then also the Z axes. And then you can control the scale along the X, the Y, and also the Z direction. We'll start adding on layers to where we're varying more and more properties at the same time, and eventually we're going to vary all of them, including the color. Let's go take a look. So this is what it looks like when you have a wave controlling the size of the objects. Here's an example of when we just allow that wave to control the rotation around about the z-axis. Let's try to superimpose 2 attributes varying at the same time, so changing the rotation according to the wave while changing the size according to a different wave. What would it look like if we wanted to oscillate the X scale of the object and then move that wave out faster than the wave that controls the rotation along the X-axis? Let's say that we want to vary the color, like all 3 of the red, green, and blue channels. I also want to try just having all of them going at the same time. That's the end of the video. I didn't think that the end was going to be right here, but if you've already seen all the results, then I guess there's nothing else for me to show. I gotta now go work on the code that will generate what you just saw. Thanks so much for watching. I'll put a link to the code in my GitHub repository in the description. It's been a crazy adventure. I've never been out here. And soon I'm gonna be moving back east, so my environment will start to look really different after that. Thanks so much for watching. I'll see you next time. Peace.